All right, let's see how you're doing. I think we did this first one in class, but I'll still show it just in case for those at home. We are called multiplying binomials here, but it's also taken into consideration the letter I, the imaginary number. So let's see if you remember the rules for both of these. You had two methods for multiplying. One was called FOIL, first, outer, inner, last, and one was called the box method. You can choose either one. I'm going to do FOIL. 4 times 3 is 12. 3 times negative 2i is negative 6i, 5i times 4i, 20i, and then negative 10i squared. So essentially we treat the letter I, the imaginary number, like a variable to start. And then now we're going to combine like terms, but we do need to take into consideration the rule for imaginary numbers. So I squared is equal to negative 1. And I is equal to the square root of negative 1. That's why whenever we have a negative under the square root, when we solve our quadratics, you can take out an I. So we're going to use this right here to say that this I squared is equal to negative 1. And negative 10 times negative 1 is just 10. So now we go combine our like terms. We have a positive 12 and 10. That gives me a total of 22 when we combine those together. And then we have a negative 6i and a 20i, and that, because they're different signs, subtracts to give us 14i. Remember that this is called a complex answer made up of a real part and an imaginary part. And it needs to be with the constant in front and then with the 14i, the imaginary part, in the back. This was called the A plus BI format. Okay, there's one of those on your final. I recommend writing it on your toolkit, covering this up, and practicing it. Make sure you remember how to do it. Okay, number 2 is a method called factoring by grouping. And if I remember correctly, I don't think I ended up including this on this year's final, but I just want you to think about this where sometimes there's a part in the front where something can come out and a part in the back where something can come out. And so if you look at this, we could factor out a 2 and an x squared from the front, leaving me an x minus 5, right? Divide out 2, divide out 2, divide out x squared, divide out x squared. And then at the back here, do you see that you could take out a 3 from everything, leaving me an x minus 5? And so here, after we grouped those together and factored them, we see that there is a commonality of an x minus 5 that can come out. And then at the back is 2x squared plus 3. And so this is called factoring by grouping. I just wanted to show it, but I think we ended up taking this out of the final. I don't think we taught this year, but it is a possibility. Next one wants us to write the equation written in vertex form and so notice here I have my vertex HK at 3, negative 5. And if I go count, out 1, up 1, out 2, up 4, this is parent stretch. And its orientation is an upwards parabola, positive. So pause the video, go write that. All right, let's see how you did. Parent stretch is just 1, x minus 3 squared minus 5. And you can put the 1 or not put the 1. It's not needed when there's an invisible 1 in front. So that's it. So how's this multiple choice final going to do this? It's going to give you a graph and want you to choose the right answer from the multiple choice. Okay, find the vertex. So you can just use this little vertex formula, or you can, if you don't remember the vertex formula, you can put it into vertex form. So I'll show you both ways. But just to kind of show you where this remind you where this came from. we know that the entire quadratic formula looks like this. And this part of the quadratic formula is this. X equals negative b over 2a. So that's how we calculate the x of the vertex when trying to find the vertex. We could just use this small part of the quadratic. Oops, forgot that c back there. What's the other part of the quadratic back here? This part is called the discriminant. It's the part under the square root, under the radical, that tells us how many roots, the nature of the roots of the quadratic. But this front part can give me my vertex. So let me show you this part. Here's my A, here's my B, here's my C. I go x equals negative b over 2 times a. Be careful with all those negatives there. And so we get positive 12 over negative 6 or negative 2. That's just the x of my vertex, negative 2 comma something. I now need to plug in to get the other part. So I do PEMDAS here. Negative 2 squared would be positive 4. Negative 12 times negative 2. So simplifying further, at the back, 24 minus 23. And I get negative 12 plus 3 is negative 9. So this just found that that is my quadratic vertex. Now, what if you wanted to use complete the square to put it into vertex form? I'm going to write it down here and then erase it. We would divide out a negative 3. So negative 3 got divided out of the front, negative 3 got divided out of the middle, and then we just make space, bumping the negative 21 to the end. Let me just reiterate, this is not number 5. This is showing you another way of doing number 4. So then we do the B work. 4 divided by 2 squared is 4. So we add 4 and subtract 4. Add 4 and subtract 4. But we have to remember that it's 4 negative 3 times. And so we get the negative 3, x plus 2 squared factors, negative 21 plus 12. And negative 21 plus 12 is negative 9. And the question that we were trying to answer from the get-go is, what is our vertex? And so now we see that it's negative 2, negative 9, the exact same answer we got up here. So which way made more sense to you? Which way was easier for you to find the vertex? Do you want to go write this little vertex formula onto your toolkit? Did that make more sense to you, or do you like doing it the way you already know, vertex form? Up to you. I'm going to erase this now because I need space to go do the actual number 5. All right, find the solutions. That means we can do any of our methods for solving the quadratic, but if you notice, doing the B work on this, that makes a fraction. We practiced that. You can do that if you want, but most people would probably use the actual formula on this because it's not factorable either. 13 times 1 does not subtract to give us 5. So here we go with the full quadratic. A equals 1. B equals negative 5, and C equals 13. All right. -5 turns into +5. On the bottom is a 2. My discriminant turns into 25 minus 52 because 4 times 13 is 52. So 5 plus or minus, grab a calculator, 25 minus 52. 25 minus 52 gave us -27. So now we're going to break down the -27, which is -1 times 3 times 9, which is 3 times 3. So a 3 comes out, an I comes out, and a 3 stays in. So 5 plus or minus 3i root 3 over 2 is my full simplified answer. What are those called? Those are called 2 complex roots, 2 imaginary roots, 2 non-real roots. That's for sure. They are not real. They have an I in it. Don't forget that. Okay, for the purposes of the lengths of these videos, I think I'm going to stop here and start the next video back up on number 6.